Okay, so whenever I think of the word algebra, a bunch of letters float into my mind. And that's because algebra is the part of math in which letters and other symbols are used to represent numbers and equations. So in math, you may not always have all the information. You may have a bunch of unknowns that you're trying to find, and we usually represent those with letters. Often we use the letters X and Y, but really any letters are fine. Just make sure you don't use the letter O because it looks too much like a 0, or the letter S, it looks too much like a 5. Let's define some of these words so that we know how to describe things in algebra properly. So first of all, we're going to start with the word variable. Variable is a letter that represents one or more numbers. So whenever we talk about variables, we're actually just talking about the letters. For example, X is a variable, Y is a variable, A is a variable, B is a variable. So anytime you're using a letter to represent an unknown, that is known as a variable. So a letter that represents one or more numbers. A term is a number or a variable or a number and a variable. And these terms are separated from one another by plus, minus, multiplication, and division signs. So let's write a couple of examples of that. Okay, so you can have a term such as 15x, or you can have a half y, or you can have just a variable by itself like x times y, or you can have just a number, negative 15. All of these are examples of terms. So terms are when you have a letter and a number combined together, or two letters combined together, or a number by itself. And when you have a long string of these, they're often separated by plus or minus signs. So for example, you don't need to write this part, but I could put a plus here, and a minus here, and now you have one term here, a second term here, a third term here, and a fourth term here. Okay, so as soon as you see plus and minus signs between terms, you know they are separating the terms up. Any questions about that? All right, what is a coefficient? Does anyone know what a coefficient is? Coefficient? If a term includes a variable, the number in front of it is a coefficient. Make sure to include the sign too. So for example, if I give you an example like negative 5a, or a half b squared, or the square root of 2x, let's figure out what the coefficients are. Whoops. Oh, okay, something is off. Why is it up there? There we go. Okay, so in this first example, negative 5 is an example of a coefficient. In the second example, a half is an example of a coefficient. And then this example, root 2 is an example of the coefficient. So what is the word coefficient mean? Anyone like with regular English words? Everything I've highlighted, what do you notice is common between all of them? Yeah. It's the number in front of the letter, exactly. And if it has a sign like a negative, then you have to include that as well. And a constant, if I have a long string of terms, so if I have something like 2x squared plus 5x minus 8y plus 7, the number that is all by itself without any letter attached to it is known as the constant. Do you see how bad this projector is? So dark, right, Nicole? So let's put everything together. I have a big example at the bottom. Again, it seems intimidating. It has fractions, it has decimals, it has letters, it has exponents, but none of it matters. All we're going to do is just use our terms to decide what everything means. So let's look at the first term that we used, and it was variable. What is the variable in every single, or in this big expression? What is the letter that we use? Good. Now, if you had more than one, you would list it with like, you would list all of them. But in this case, our variable is just the letter y. Do you need to write y cubed, y squared? No, a variable is only referring to the letter. So if I'm asking you what the variable is, I'm just asking you what is the letter that you can find. If this wasn't a y, if let's say this was an x, you would just say y comma x. So you would just basically list all of the letters that you can find in this expression. Okay, let's look at term and figure out how many terms there are. Remember, a term is when you separate a plus and a minus sign. Sorry, a term is separated by a plus and a minus sign. So this right here is one term. Then this right here is a second term. And then a third term. And then a fourth term. And you notice the sign in front of the letter and the number is included. So this term right here, I'm going to call negative 5y cubed. This term here is positive 0.8y squared. This term here is positive a half y. And this term right here is negative 7. So how many terms do we have in this? There are 4 terms in this, yes. Because 4 things are separated by plus and minus signs. Okay, let's look at the coefficient. Almost wanted to be this. That's good. What is the coefficient of the, and by the way, when you're labeling your terms, you would call this term number 1, term number 2, term number 3, and term number 4. Okay, so now I'm going to ask you, what is the coefficient in the first term? Abrami? Good. I'm just going to highlight it so you guys can see. The first term, the first coefficient in the first term is negative 5. What is the coefficient, and what is a coefficient? It's just the number in front of the letter. What is the coefficient in the second term? Javen? 0.8, yeah. And you don't need to say positive, but just know that it is a positive. What is the coefficient of the third term? Sirsha? Sorry. Yep, positive 1/2. Good. And then Nicole, actually, I'm not going to ask anymore. I'm just going to leave it like that. So our coefficients are so they're negative 5, 0.8, and a half. Now, how come I didn't highlight negative 7? Is negative 7 a coefficient, or does it have a different fancy word for it? Nicole? Good. So we're going to actually write that in our last definition. Our constant is it a positive 7 or a negative 7? Negative. Make sure you include the negative sign with it. Good. And if we are highlighting, then I can just highlight this with orange so you can see that it's different from the other ones. Okay, go ahead and practice doing this with the chart at the back. So I've given you 3 different expressions. I want you to tell me what the variables are, what the terms are, what the coefficients are, and the constants. I'll give you 2 minutes while I take attendance, and then we'll take it up. Done. Can I get one volunteer to tell me all their answers for the first, what's this called? Row. Nicole, go ahead. What are the variables in this? Yep, and how many terms do we have? Good. What are the coefficients? Yep, and you actually do have to do them in order. So you're going to say 1 and then negative 3. And then what is the constant? It's going to be positive 7. Good job. A volunteer to do the next one? Abrami, go ahead. A and B. Good. Do you guys notice how for the variables, we're not writing a squared? I'm not asking for what exactly. I'm just asking for what are the variables in general, okay? How many terms are there? There are 3. And what are the coefficients? 5 and -3. And what's the constant? +2. Yep, or 2. Perfect. And then a volunteer for the third one, which is probably the hardest. Javen, go ahead. What are the variables? The variables, what are the letters? For question, the third one. D, C, and F. Yep. And how many terms are there? So in order for me to figure out the terms, I look at how many plus and minus signs there are. So there's 1 term here, a 2nd term here, a 3rd term here, and a 4th term there. So there are actually going to be 4 different terms. What are the coefficients? So tell me, what are the numbers in front of all of them? Yep. And then don't forget the first one. What's a term in front of the first? What's a coefficient in front of the first term, you guys? Yeah. So we're going to write -1. And then you got the second one right, 3. Then you got the next one right, which is -100. And then Javint, what is the constant? It's going to be +90. Excellent. Any questions about these, or do they make sense? You guys are okay with them? Yeah, okay. What are like and unlike terms? So this is what that little tree exercise you guys were doing was helping you figure out. I'm going to write a bunch of like terms together, and I want you to tell me what you notice is the same. Okay, so I will do maybe 3 examples to show you for each, and so you can see the pattern. So this will be the first example, and then I'll do a second one here. And then for unlike terms, I'll do the same thing. Because I do think that for this, the best way to think about it is just by looking at a bunch of examples. Okay, so here are a couple of examples of like terms. 3a squared, -5a squared, and 8a squared. What is the same between all of these terms? Oscar? Yeah, the letter or variable, which is a, and the exponent squared are all the same, which is what makes it the same. What is different about them though? Oscar? Yeah, exactly, the coefficient. So that tells you in order for something to be a like term, the coefficient, the number in the front doesn't matter as long as the letters and the exponents are the same. All right, let's try another one. How about, let's do a half xy and then 0.8 xy and -9 xy. Do you notice for all of these that they all have the letter x and they all have the letter y? And the coefficients are all different. You guys, I can also write it like this. I can have xy, xy, and yx, and they're still the same. Why are they still the same? Nicole? Exactly. The order does not matter. They still have the same variables. As long as they have an xy, xy, y, xy, that's fine. You can even rewrite one of them as x times -8 times y, and it would still be a like term because it still has the letter x and the letter y. The order does not matter as long as they're both present. Okay, I'm going to show you one that seems super confusing. -2a cubed b squared c, and then 5c a cubed, and then b squared, and then 1/8 b squared c a cubed. Are these all like terms? And if so, tell me how you know. 1 second. This is acting up. Can't click away. Seer, should I see your hand? 1 second. There we go. Put this back in and then share my screen. Okay, Saoirse, why are all of these like terms? Exactly. So every single one of these terms has a cubed, b squared, b squared, b squared, c, c, c. The numbers in the front don't matter. What if I had accidentally, though, written c squared? As soon as you change one of the variables or exponents, it's not like terms anymore. I'm going to give you 3 examples of unlike terms, and you can try to figure out if they make sense. So an unlike term would be something like 2a, 2b, 2c. These are unlike terms because none of the variables are the same. Even though the coefficients are the same, you need the variables to be the same. Okay, another example would be negative 5x, negative 3x squared, negative 8x cubed. Again, are the letters the same? Yes, but are the exponents the same? No. So we need the letter and the exponent to be the same. Another example of unlike terms are, let's say we have 3a squared b, negative 5a squared b squared, and then negative 8ab squared. Again, even though all of the letters are the same, the exponents are not, they don't match, and so they're considered to be unlike terms. Okay, so when does this come? Why is this important to us? Because there's actually a rule in algebra that says when you're adding and subtracting terms with variables in them, you're.
Please excuse this interruption. At this time, can we please have all attendants submitted online or to the main office? Thank you.
You're only allowed to add and subtract terms that have the same letter and the same exponent. If you have a different letter and a different exponent, you're not allowed to add or subtract those terms together. So let's try doing that with the collecting like terms activity. Okay, so I have 5x minus 6y minus 2x plus 2y plus 1. And I'm basically asking you to collect like terms and then try to solve this. So what are like terms? I'm going to highlight some of them. If I have a 5x here, what looks like a 5x? Negative 2x, good. So 5x and negative 2x are like terms because they both have the same letter and the same exponent. Okay, great. Let's try another one. What looks like negative 6y? Is that too similar? Maybe I'll try green. Saoirse, what looks like a negative 6y? Positive 2y, good. And is there anything on this sheet that looks like a positive 1? Is there anything that is, in other words, is there any other constant? No. So that positive 1 stays where it is. Okay, now we're going to start collecting like terms. So I am going to rewrite this. So all of my x's are written together, all of my y's are written together, and all my constants are written together. If I want to put my x's together, what 2 numbers am I going to start with? You can just say them out loud. Yep. I need to just zoom out a little bit because this is awfully big. There we go. So we're going to put 5x and then negative 2x together. Good. Now I'm going to put my, and by the way, do you notice how I'm keeping the sign in front of them? The 5x was positive, so I kept that as positive. The 2x has a negative sign, so I keep the negative there. I don't put commas. I don't do anything else. I just list the numbers as they appear. Now let's put our y's together. So what are the 2 y's that we're going to put together? Saoirse? Negative 6y and positive 2y. And I realized that if I maybe keep the colors the same as what's highlighted, it might be slightly easier to follow along. Okay, again, do you notice that I just wrote them as they are? I didn't put commas, I didn't put them separately. They're all in a string of terms. And then to end it off, we're going to have our constant, which is just going to be a positive 1. Now, here is the rule in math. I'm allowed to add these x's together. I'm allowed to add these y's together. And if there were constants, I'm allowed to add them together. But can I add an x and a y together? No. Can I add a y and a constant together? No. So I'm going to now put everything together and see what I get as my final answer. Okay, let's go ahead and try it. And we're just using integer rules. So what is 5 minus 2? So it's just going to be a 3 and an x. You don't write x squared. You don't do anything like that. If they're two like terms, you just keep the variable, whatever was in the question, you keep it in the answer. Let's try, what is negative 6 plus 2? Different signs, subtract the numbers, take the sign of the bigger number. Javen? Good. It's going to be negative 4, and I'm just going to glue the y to it. And I don't have anything related to my constant. So what am I going to do with that? I'm just going to keep it as is. It's just going to be a positive 1. If I had another constant, I would add it to it, but I don't. That would be our final answer. All right, so I'm going to do the same thing I did before. I'm going to go ahead and color code a little bit. Oh no, I lost my nice orange. So I'm going to start with my A's. I see I have a positive A here and I have a positive 3A here. So I'll just highlight those orange. And then for my B's, I see I have one negative B and nothing else. That's good. And then for my C's, I have a negative 2C here and a negative 5C here. And then finally, for my constants, I have a negative 11 here and a positive 16 here. So now I'm going to start to put everything together. If you're wondering what order, whenever you have different alphabets, you should always do an alphabetical order. So you should start with A and then go to B, then C. So I'm going to put my A's together. When I do that, what do I get? Yep. So before I even solve, I have a positive 1A plus a 3A. Now I'm going to put my B's together. I only have one B, which is a negative 1B. What'd you guys get for C's? What did you put down for C's? What are the two C's that you have? Saoirse? Negative 2C and negative 5C. Whoops. Yep. And then what did you get for the constants? Good. Now I'm allowed to add my A's together. I can add the B, which doesn't have anything with it, the C's, and then the constants. And I'm going to put them all together and see what I get. So what is positive A plus 3A? Positive 1A plus 3A. Positive 4A. There's nothing to go with the B. So what do? I just leave it there. I just need to write negative B or negative 1B. What's negative 2C minus 5C? Aritra? Negative 7C. Good. What's negative 11 plus 16? Positive 5. Anyone get that as an answer? Yeah, you did? Okay. We're almost done this lesson. I just have 2 more examples to show you and then we're done. Before I go move from this page, just note your homework is on the bottom left-hand side of the page. But before we practice on our own, turn to this sheet as well. We're not going to do all the questions. We're actually only going to do one of them. On the bottom left-hand side of the page. Nope, on that same page we were just on. See the textbook questions? They're written on the bottom left-hand side. Okay, like I said, I just need 5 more minutes. There are a couple of terms that we use when we're describing polynomials, okay, or when we're describing expressions. If you have only one term, that is called a monomial. So for example, if you have something like 4x to the power of 5, it's just one term, I'm going to call this a monomial. If you have 2 terms, like 4x to the power of 5 plus x squared, that is called a binomial because it has 2 terms. And if you have three terms, like this example here, that is called a trinomial. And you know these words, right? Because when you were little, you rode a tricycle. It had three different wheels. Now you're older, you ride a bicycle, which has two wheels. Monomial, does anyone know what a monocle is? Yeah, so, or yeah, exactly. Or a unicycle, which doesn't really work with this. We're gonna skip all of this degree stuff. We're gonna go just to the back page, and that's the example we're doing before we stop. So when you have an expression like this, an algebraic expression with a bunch of terms, a bunch of variables, we are gonna learn how to put them in different orders. So there's something called ascending order and descending order. If you're climbing up the stairs, are you ascending or descending? Good. Ascending means going up. And if you're going down the stairs, you are descending. Okay. So if I have this expression, and I ask you to put it in ascending order, it means I want you to start with the smallest exponent and work your way up to the largest exponent. Okay, so what does that look like? Which one of these terms has no exponent at all? Okay, we're going to start with that. We're going to put 7 over here because it has no exponent at all. What is the next higher exponent than 7? Than nothing. So look at all the exponents. We have a 2 here. Technically, we have a 1 here. And then we have a 3 here. So what is the next large? If 7 is an exponent with nothing in it, what's the next higher exponent? Yeah, Ari? Yep, you got it. Negative 5x1. Good. What is the next higher exponent? Yep, and what sign is in front of the 2x squared? Is it positive? So it's going to be positive 2x squared. Yep. And then what's the next higher exponent? Positive x to the power of 3. This is called ascending because we started with the smallest, which was nothing. Then we went to 1, 2, and 3. Now, descending means you're going the other way around, but look, we've actually done the hard work. If you've written this in ascending order, what do you need to do to this to write it in descending order? Just flip it. So we're going to start with x cubed. Then what are we going to write next? Positive, don't forget your signs, positive 2x squared. Good. What are we going to write next? Yep, and you don't even need to write the 1. And then what's the last number? Positive 7. Good. Make sure as you're doing this though, you guys, you're remembering to put a sign in between everything. So that's super important. You can't write stuff without signs in between. That's pretty straightforward, right? Okay, one last example, then we'll stop. That's the end of our lesson. Ascending and descending? Yeah, that might be a new grade 9 concept. No, we always teach this. Anyone want to volunteer to try this? Abraham, go ahead. So ascending means you start with the smallest one and then you go up. Even before 8x, what is smaller than an exponent of 1? Yeah, a constant is actually the smallest because it doesn't even have an exponent. So negative 6. And I'm actually just going to cross it as I do it so I remember which ones I've used up. What's higher than exponent of 0? Yep, positive 8x to the power of 1. Good. Then? Before that, there's something else before that. Nicole, do you see it? Positive x squared. And I really, really liked how Nicole wrote positive. So remember, if there's nothing written here, it's like a positive 1. You have to make sure to include that. Okay, Abraham, keep going. Yep, negative 4x cubed. And then the last one? Good. So look, we started with the 0, 1, 2, 3, 4. Descending is easy. You just flip it. Anyone want to try that? Maybe someone I haven't heard from that really wants to say something. Okay, go ahead, Saoirse. Yeah, descending order. Good job. Good. And I'm actually not even going to assign the textbook questions for this one. You don't have to do this because this is such a short, actually, you know what? Maybe just look at it and I'll just leave it at that.